Attack Terrain by Luca Barchi. What is it? It is a mock combat game created in the mid 1900s where toy spears are made from long grass, reeds, and rushes that were thrown at the opposing players. They are often also used a toy wooden stick, also known as a woomera. How to play. The game is played with two teams standing on each side of the field. Each player has a spear. Your team scores a point for the round when they get everyone out on the other side. To get a player out, a spear needs to touch them without hitting the ground. This traditional game was played by boys and girls ranging from younger ages to teenager ages. In the years as we are in 2021, this game is now called dodgeball. This game is very popular and played by many. Kinematics, projectile motion. The simple game has a lot of physics behind it, starting off with kinematics. This game would be played on Earth is mostly projectile since there are objects in projectile motion. The spear being thrown around shoulder height experiences three different types of projectile. The first being thrown in an upward motion. This would result in a very high but close shot or a far shot. The best angle for the best distance to throw the spear out would be 45 degrees. The second being thrown along a horizontal path. This wouldn't go as far and would not be efficient in the game since they played in large fields and had to throw far. The third being if it was under what would be a horizontal path. This would be the worst throw to have since it would just go straight to the ground, and depending on how low you throw it, result in injuries to the player throwing it. Kinematics, velocity, acceleration, relative velocity. Other kinematics in this game while being played on Earth would be velocity, acceleration, and relative velocity. The velocity part of this game is all about the spear. It starts gaining velocity when the player is about to throw the spear to when it hits the ground, or the other player comes to a complete stop. Acceleration happens in different ways. The first way is when it throws up and loses velocity, then accelerates as it starts to travel downward. That is the only instant where you have acceleration and deacceleration in the same throw. All the other throws that are horizontal or more towards the ground will only have acceleration because it comes to a stop at the end of the path for the spear. There is a bit of relative velocity in this game. The frame of reference for each of the players is different with respect to each toy spear being thrown. Kinematics, crash and chase. There is also a crash and chase that happens in my sport. The crash would be a player running into the spear when it is traveling towards them. This happens a lot during my games since the players have a lot they need to look out for and won't always see what is coming at them. Chase would be a player running back and the spear chasing them and catching up to them. This also happens a lot because kids would throw the spear, run as far back as possible, and have spears being thrown right back at them. Newton's law of relation. First law is every object in a state of uniform motion tends to remain the same unless an external force is applied to it. A spear on the ground will stay there. This means that unless a force is acting upon the spear, whether it is on the ground, it will not move. B. A spear thrown will continue unless acted upon by another force, such as air resistance or a player picking the spear up. This means that the spear will continue a path unless something stops it, like the ground or a player hitting it down. Second law, the relationship between an object's mass acceleration and the applied force is force equals mass times acceleration due to gravity. A spear's mass and acceleration determine how much force the spear will impact on another person. This means that not all the spears are the same, and some might be heavier or lighter depending on how they were built. Thus, the spears could have a larger force or a smaller force depending on the mass. Third law, for every action there is an equal and opposite reaction. If a spear is on the ground, the force that is applying to the ground is the same as the force the ground is applying to the spear. Therefore, if the spear is putting 10 newtons on the ground, the spear feels 10 newtons of force back at it. It's the same reason why your hand hurts when you hit something. The same amount of force it felt on the part of your hand that hit the object. Kinetic forces. On Earth, the next unit that has relationship with the sport is kinetics, also known as our forces unit. The force action on the spear is force of gravity pulling the spear down and the player all the time. Normal force, the force that is acted upon the object at all times unless it is in the air. The force being applied, which it is pointing in the direction, is moving, is the applied force. The applied force is either parallel to the ground unless the object is on an angle, in which we use the angle to calculate the force being applied. This force occurs when throwing a spear to move it and give it an acceleration. In microgravity. Being in microgravity, things change a bit. Obviously, your force of gravity changes due to the weaker gravitational pull on the object. The next thing to be changed is the force of friction. The force of friction is less due to the less force the object has or is being pulled by, and the less force it has on the surface because it would be lighter. The last force to be changed is the applied force. The applied force changes because the object becomes lighter, and moves almost freely in microgravity. Therefore, knowing that your applied force changes, this also changes your work. Work is based off your applied force. So if your applied force is less, that means work is less, which results in less energy. In macrogravity. Being on a planet with much greater gravity, this changes the forces acting upon an object totally opposite than microgravity. The force of gravity changes and makes everything travel to the ground at a much faster rate compared to micro, which it would fall very slowly. Your friction force is much greater than regular, and the same with the force applied. So if your force applied is increased, so is your work. Momentum and energy. Another unit is momentum and energy. The energy is used for the spear through the air. If you throw the spear, it has a certain kinetic energy as it flies towards its target. The energy of this is based on how fast you can get the spear to move at the start, with the initial velocity. The kinetic energy will remain the same if you neglect all air resistance. With elastic potential energy, we use a spring, but with the arm of the player, it's acting like the elastic. The player could pick up the spear from the ground, pull their arm back, and throw the spear. Therefore, their arm acted like a spring. Conservation of energy. Energy is always conserved because of the laws of conservation of energy. This means that energy cannot be lost nor destroyed, and it either goes from potential energy to kinetic or vice versa. In my game, this is happening a lot because the spear is having to be moving all the time, and same with the players. It is a game where you do not stop as much. Now, with relation to my game to potential energy, it is when a player is holding a spear and getting ready to throw it. That is where the potential energy is. In relation to kinetic energy, when the spear is thrown, the spear gains velocity. This gives the spear its kinetic energy. Momentum and energy. Work on Earth. Work is shown through how much you move your arm and how far the spear has to fly. The spear is displaced, and the force you throw it with, it is the amount of work the spear made. Work on microgravity. Microgravity changes the amount of energy you need to move an object because of the force applied. With microgravity, the amount of work is so small compared to regular gravity on Earth. In macrogravity, with greater gravitational pull on a planet comes a greater amount of energy needed to move an object. If a planet has a greater gravity than just regular Earth, the amount of energy needed to move an object increases. On Earth, elastic collision. When a spear is thrown and doesn't stick into the ground and it bounces, it is an elastic collision. Gravity is pulling it down, and the velocity of the spear is keeping it from just stopping and bouncing. Each time it hits the ground, it loses velocity to friction, which results in the loss of momentum. It also loses some kinetic energy and does not bounce as high, which in return reduces its potential energy. Microgravity. Elastic collisions change a bit as well because of such low gravity and the very different speeds the spears are going to be traveling at. They will bounce off the ground at a much faster speed and travel much farther than just the regular gravity and it actually being pulled to the ground with a force. In macrogravity, elastic collisions are a weird one because of the greater gravitational pull. The spear would not bounce as much or even bounce at all, resulting in less elastic collision. The end.